Welcome to Dialogue Doodles. I'm your host, Jack, and today we're diving into one of the most fascinating stories in scientific history. With us is Professor Henry Matthews, a renowned expert in Renaissance science. Henry, welcome to the show.
Thank you, Jack. It's great to be here to discuss one of history's most brilliant minds.
It's interesting. In 1564, when Shakespeare was taking his first breaths in England, another Renaissance giant was born in Italy, a man who would completely transform how we see the universe.
Absolutely. Galileo Galilei was born in Pisa on February 15th, 1564. And what's fascinating is that he came from a family of musicians, not scientists.
That's unexpected. How did someone from a musical background end up revolutionizing astronomy?
Well, it's quite a journey. His father, Vincenzo, was actually a renowned music theorist who conducted groundbreaking experiments with string tension and pitch. In many ways, this early exposure to experimental thinking shaped young Galileo's approach to science.
So there was already some scientific methodology in his childhood environment, even if it was through music?
Exactly. But here's where it gets interesting. Galileo was actually pushed toward a medical career. His father wanted him to become a doctor, which was seen as a more profitable profession.
I imagine that didn't quite work out as planned.
Not at all. While studying medicine at the University of Pisa, Galileo became fascinated with mathematics. Legend has it that he was sitting in the Pisa Cathedral in 1581 when he noticed something remarkable about a swinging chandelier.
The famous pendulum observation?
Yes, that famous pendulum observation. He noticed that regardless of how wide the chandelier swung, it seemed to take the same amount of time to complete each swing. He actually used his pulse to time these oscillations.
That's remarkable, using his own heartbeat as a scientific instrument. It really shows his innovative thinking from the start.
It does. And this observation led him to drop medicine entirely and pursue mathematics. By 1586, he had invented the hydrostatic balance for measuring the density of objects.
These early inventions seem to show a pattern, taking existing ideas but improving them dramatically. Did this approach continue throughout his career?
Absolutely. This became his signature approach. By 1592, his reputation for practical innovation helped him secure a position at the University of Padua, where he spent what he later called the happiest 18 years of his life.
The happiest years. What made this period so special?
Padua offered him incredible academic freedom. He could pursue his research interests, develop new instruments, and most importantly, challenge existing ideas without significant interference.
Speaking of challenging existing ideas, this brings us to perhaps his most famous period, his work with the telescope. How did he make that transition from studying motion and creating measuring instruments to astronomy?
That's a fascinating transition. In 1609, Galileo heard about a Dutch invention, a spyglass that could make distant objects appear closer. But rather than simply copying it, he did what he always did. He improved it dramatically.
I understand he made quite a leap in its capabilities.
Indeed, the original Dutch spyglass could magnify objects about 3 times. Through careful experimentation with lens grinding and positioning, Galileo created a telescope that could magnify objects up to 20 times.
To put that in perspective for our listeners, it would be like going from a pair of reading glasses to a powerful microscope.
And what makes this technological leap even more remarkable is what he chose to do with it. Instead of just using it for terrestrial observations, Galileo did something revolutionary. He pointed it at the night sky.
Something so simple, yet no one had done it before.
Exactly. And in January 1610, this led to one of his most stunning discoveries. He noticed 4 points of light near Jupiter that changed position night after night.
Jupiter's moons.
Yes, he realized these were moons orbiting Jupiter. This was absolutely revolutionary because it showed that not everything in the cosmos revolved around Earth, as was commonly believed at the time.
It's like discovering a miniature solar system within our own.
That's a perfect analogy. And he didn't stop there. When he turned his telescope to the moon, he saw something that contradicted centuries of belief.
The moon's surface wasn't perfect and smooth as everyone thought, right?
Precisely. He saw mountains, valleys, and craters. This challenged the ancient idea that celestial bodies were perfect spheres. He even calculated the height of lunar mountains based on their shadows.
These discoveries must have caused quite a stir in the scientific community.
They did, and Galileo knew exactly how to publicize them. He published his findings in a book called Sidereus Nuncius, the Starry Messenger, in 1610. It was written in Latin, making it accessible to scholars across Europe.
And then there was his observation of Venus, which I understand was particularly significant.
Yes, this was perhaps his most compelling evidence for the Copernican system. He observed that Venus showed phases, just like our moon. This could only be explained if Venus orbited the sun, not Earth.
It's amazing how these observations, which we might take for granted today, were completely reshaping humanity's understanding of our place in the universe.
And what's particularly fascinating is that when Galileo looked at the Milky Way through his telescope, he discovered it wasn't just a cloudy band of light. It was composed of countless individual stars.
So he was literally expanding the known universe?
Exactly. And think about this. Every time he looked at something through his telescope, he was seeing something no human had ever seen before. It must have been absolutely mind-blowing.
It's interesting to think about how these discoveries parallel modern scientific breakthroughs. We're still using more powerful instruments to challenge our understanding of the universe.
That's a great point. The basic principle remains the same, using new technology to gather empirical evidence. In fact, the European Space Agency named their satellite navigation system Galileo in his honor.
Looking back at his journey from a medical student to this towering figure in astronomy, what do you think was his most important contribution?
While his specific discoveries were groundbreaking, I'd say his most important contribution was his method. The combination of careful observation, precise measurement, and willingness to challenge established beliefs with evidence.
The foundation of modern scientific method.
Exactly. He showed that truth should be determined by evidence and observation, not by referring to ancient authorities. He famously said that the book of nature is written in the language of mathematics.
And here we are, over 400 years later, still reading that book with ever more sophisticated tools.
And finding new chapters all the time. Every space telescope we launch, every new instrument we develop, follows in Galileo's footsteps.
Well, Henry, this has been a fascinating discussion. Any final thoughts for our listeners about Galileo's legacy?
I think Galileo shows us that real scientific revolution isn't just about new discoveries. It's about new ways of thinking. He taught us to question, to observe, and most importantly, to let evidence guide our understanding of the world.
Thank you, Henry, for sharing these insights about one of history's greatest scientific minds. And thank you, listeners, for joining us on this journey from the swinging chandeliers of Pisa to the moons of Jupiter. Until next time, keep looking up and questioning everything.